So welcome everybody. As you can see, Dr. White has joined us today. So be on your best behavior. So I wanted to do something just a little bit different today. In that I need to pull up my emails. Here we go. So this whole seminar has been a really interesting snowball effect that started with the idea of just having one or two quick sessions on how to use AutoCAD. And between support from different people and ideas from different people, it's really kind of turned into something that I think is really cool, and I'm really glad to have been a part of. And so I just wanted to take time and recognize everybody for what they've put in. There's been, some really good feedback, really good participation and effort shown by everybody, both this quarter and the previous two quarters. And so I feel like we've made something really special here. So I just wanted to take a few minutes and recognize everybody. First and foremost, man, I really didn't organize my notes very well. So first and foremost, I'd like to extend a really heartfelt thanks to Dr. Jason White for all the time and effort that he's dedicated to this class. It's really outside of his official job description, and he could have very easily told us to, figure it out ourselves. But instead, he's put in a lot of time and effort and shown a lot of patience as we stumbled and bumbled through this. And thanks to him, we have some kind of official recognition under the school, and I think it's really helped keep this whole effort going through the entire process, whereas it may have fizzled out, without that official recognition. So thank you, sir, from the bottom of my heart and on behalf of the entire class. We couldn't have done it without you. And on that note, I'm going to turn it over to Dr. White.
All right. Well, thanks, John, and thanks for the recognition. But I do want everyone to know that it really is my pleasure to allow you guys to have this opportunity, and it's really I don't feel deserving of what John said, honestly, but I'm very glad that you guys were able to do this year. And John has invited me to recognize some of you that have put in some special effort this quarter. But before I get to his list, just to something I was going to say, and I think you all know that this would not be happening if it weren't for John. John has really done everything to really make this happen. I've just been kind of opening doors, but I want to make sure that John is recognized as the person that made this all happen, and hopefully has set the stage here for future courses being able to benefit from this idea, and also just from the educational experience that we now have that is above and beyond what our students get in our typical curriculum. So thank you, John. You're the one that really deserves the recognition here, I feel like. So.
Woo!
All right. So on that note, yes, give John a round of applause. So I have a few different categories to announce some special recognitions in. So the first special recognition is to those who completed all of their assignments on time this quarter. Given that this is definitely an extra for everybody, this just kind of shows your dedication above and beyond the call of duty. So I will now announce those folks, and if I do mispronounce your last name, I sincerely apologize. I'm pretty terrible, but I will do my very best. And so those following folks who received this special recognition for all assignments completed on time, spring quarter 2020, are Evan Arifrain, Isaac Deguchi, Andrew Holmes, Bora Hong, Mason Leiden, Haruka Shudo, and Amandeep Singh. So congratulations, and thank you everybody for your extra special effort this quarter to get all of your assignments in by the deadlines. Round of applause. All right. Silent round of applause. Canvas, or not Canvas, Zoom needs some confetti or something that flies down, I guess, when you say certain things. There we go. All right, we got Andrew giving a round of applause. All right, next special recognition is to the panel drawings and assembly team. And so many of you have been involved in this course now for multiple quarters. And one of the really awesome things that, again, John, your fearless leader, did was solicit some donations from Automation Direct to get some components that you could all use to set up a demo panel. It just sounds like you're now working on programming. And so we want to recognize the people that spent additional time outside of the scope of the regular seminar to ensure that this project is moving forward to completion by helping to put the panel together, by working on the drawings, attending extra workshops. And so those people that we like to recognize are Natalie Ruska, Sam Clark, Josh McMillan, Evan Arifrain, Mason Leiden, Amandeep Singh, Samaj Trope, and Evren Vikaki. So thank you everybody for your special extra effort. Round of applause. Woo. All right. And the last category. And this is a special recognition for the panel drawing set completion. And so completing the panel drawings and verifying that all the details are accurate took a significant amount of time, on the order of 30 hours of work, I'm told. And so for the extra initiative on this effort, putting in the time to finalize this invaluable deliverable, we'd like to especially recognize Amandeep Singh. Thank you, Amandeep. Woo. And again, thank you. I'm very glad that you all were able, to benefit from this class. And thank you again, all. And thank you, John. And thank you for involving me in acknowledging all these special recognitions. So, thanks.
Thank you, sir. So there you have it. Hopefully this class is going to be continuing next year. For those of you that aren't graduating, we're working on making this a possibility next year. Obviously, due to the current craziness going on, we're not sure exactly what that's going to look like, but hopefully it'll be around and available to you next year if you want to continue. So my plan for today was to show you that perfectly executed bit of code for that PID control loop. And as most of you heard, about 5 minutes before we started, I'm still online with tech support with Automation Direct. So I think we've got it figured out. And it actually is self-tuning. But at this point, I still got to play with some stuff and make sure it's actually working. So I'm just gonna share my screen real quick so you can see what's happening. So this is pretty much the same code we went over on Monday. And so what I've done is I told it to run at 50%. And you can see from this hysteresis graph, it is gradually, very, very gradually increasing the output and trying to close that gap between the set point and the process variable. So the red value here is the set point. The green value is the actual process variable that's being read. And then the yellow here is the output on the PLC. And so you can see in the code here, it's kind of creeping up towards that value. But what I'm going to try to do here is change some of the loop parameters and see if we can close that gap a little faster. So the first thing I did is just reset that, or decrease the integral gain, which is the reset time. And as you can see, it's now closing that gap way, way faster. So the next thing I'm going to do is increase the proportional gain. See if that'll let it act a little bit faster. That looks like it's acting a little bit faster too. So for those of you that have been in 157, you'll have a little bit better idea of what's going on here, but it looks like this loop is now self-tuning and actually working correctly. So you can see it increased, overshot a little bit. Now it's undershooting and it's creeping up back towards the set point we have. And so this is pretty much how you tune a PID loop. You sit there and you play with these values until they get dialed in pretty well, and you get the speed of the response you like. So right now I have the set point set at 50. So we're close enough to 50 that I'm pretty happy. If you look at on my screen the PV process raw value, that's at about 50%. That's pretty good. So I'm gonna bump it up to 100 and see if we can get this thing dialed into the 1725 RPM that we actually want out of this motor. So you can see the set point, the red line jumped up to 100 as soon as I changed it. And now that green process value, which is being read as, you know, the actual process value for this thing, that hit it pretty quick. That's actually about 30 seconds. It's now really close to the value we want. So you can see it's a little undershot, and I'm going to change my camera to the GoPro, which will hopefully work. There we go. Can you guys actually read that screen, what's shown on the screen? Yeah, it's probably too small.
I'm gonna like switch back and forth.
Yeah, I'm gonna do stop share. Okay, so now hopefully you can see on my screen, it's about 1715. So what I'm gonna do is again decrease that integral gain and see if it'll tighten up a little bit faster. So we are at, oh, there we go. So plus or minus 10 RPM, that's pretty dang good. I would say I'm pretty happy with that. Plus, considering the way we're measuring this RPM off a piece of tape spinning past a laser sensor, there's going to be a little bit of inherent error in that measurement itself. So overall, I would say this is pretty dang good. And what we've done is use that PID loop the way we talked about to dial in the output from the VFD to get the exact motor speed that we want, because somewhere in here we have a physical constraint that's causing our motor to spin a little bit at a little bit different speed than what we want. So we did it, guys. It actually works. So just for my own curiosity, I'm going to check. So the VFD is bouncing around at about 58 hertz, give or take, output to that motor. So there's probably things we could do to actually clean this up even more. I'm gonna share my screen again. So there's in this PID loop. So right now, what we're doing is we're calculating the exact motor RPM, and then we're just jamming that straight into our PID loop as the raw process variable, right? So one of the things you can do is add a process variable filter, and that basically, because our RPM is jumping around like crazy, if you add a filter, it basically kind of smooths out your data. And this is what I was talking about before, that we were doing manually in the code. I actually got rid of all that data filtering because it was really, it was introducing more error than it was fixing. So pro tip for industrial automation, if somebody already wrote some kind of algorithm to do what you want it to do, use their algorithm. Don't try to program it from scratch like I did. So I'm gonna change the filter. I'm gonna give it a 50% filter and see if that kind of smooths it out a little bit and lets us hit that that RPM. Yeah, that looks better actually. So I'm gonna actually increase or decrease that filter to 10% and see what happens. Cool. That looks pretty dang good. We're pretty much hanging out exactly on 1725 now. So, I'm gonna change my camera back. So I know that was probably a little bit abrupt and maybe it not perfectly fresh from what everybody saw from last week. So I'm super happy that we got that working, and that was really the last accomplishment I wanted to hit for this quarter. So I'm gonna turn it over for questions and anything else you guys might have to say about the experience and about the quarter.
What was that filter that you applied? What does that do?
The process variable filter. So this is more black magic that I'm not going to promise I have a perfect explanation for, but basically what this is doing is like our raw process value, our RPM reading from the field is jumping around like crazy, right? Because partly because of inherent error in our instrumentation, but and the way we've set up the program basically. And so what this filter does, I believe, is it basically every new piece of data, it uses that as it keeps like a running tally basically. So instead of just saying, oh, my process variable is what I just instantaneously read, it keeps like a running average of all the process variable readings you've taken for the last 30 seconds or whatever. To be perfectly honest, I'm not 100% sure that that's true.
So it kind of like smooths out the process data?
Yeah, that's the idea, but
Okay.
It doesn't seem to be working very well. So I'm going to actually take that off because we're not hitting our target anymore. I'm gonna let this guy tune itself back out because that introducing that filter actually seemed to introduce problems, not solutions.
And gain is just, that refers to just the thing that pushes the process value towards the set point?
Yeah,
Okay.
exactly.
And the different kinds are just different algorithms?
The different what now?
They're like different algorithms that the software uses to do that?
So, are you talking about the PID?
Yeah.
Those different modes? Yeah. So the proportional gain is basically a direct correlation to the amount that you change your output. And then the integral gain is I probably shouldn't try to explain this because it's based in the way that you derive the control algorithm using Laplace transforms and stuff.
Okay, so we do this in 157.
Exactly.
Bunch. Ah, cool.
So, and it looks like I made those changes to the gains, and it looks like it's actually making it worse. So I'm switching this back to see if I can get it back on target. So we got it working and broke it all in one session, guys.
Sounds like an accomplishment to me.
Yeah. Definitely on track as far as performance history goes. I don't know why this thing's slowing down, dude. I'm starting to wonder if we're getting instrumentation error. Because it keeps dropping off. But I don't think it's actually slowed down at all. Oh, you know what? I think we are having instrumentation error. Let me slow this down. Okay, so I think what was happening is it was spinning so fast the tape was actually bending and not triggering correctly. At least that's my hope. Oh. There we go. That's looking better. So that's totally going to tune itself. Guaranteed. Anyway, like I said, I'm not an expert on automated control systems and PID loops. I just wanted to kind of introduce that and show that you can implement these automated control systems on fairly rudimentary hardware if you've got the time and patience. And to be honest, in this software, it's pretty easy to implement overall. So science can be fun, guys. Anyways, I mean, at this point, we can keep watching this thing tune itself all day. But that's what I had. So just once again, thank you guys for a great quarter. Thanks for all the hard work that you put in. And I hope you at least learned a little something and you're more comfortable going on and looking into these things on your own. And you now have a library of some interesting, albeit random documentation available that's hopefully related, hopefully helps clarify certain things under the Davis curriculum.
Thank you, John.
Anytime.
Multi-wise.
Thanks, John. Good luck, everyone. Hope everyone has a good end to their academic year. And congrats to those who are graduating.
Thank you, sir.
You know, Troy.
I think that's a good percentage of everybody in here.
Definitely doesn't feel like we're graduating.
All right, I'm gonna kill the recording.
Can you actually hear the motor